Hello everyone, welcome to our last video lesson for chapter 3. We're on 3.6 talking about perpendiculars and distance. Before we dive into the lesson for today, just think with me here for a moment. If I draw a point right here, and I draw a line right there, just out of curiosity, what is the closest distance from the red point to the green line? Now obviously, it's not this line. That distance is not the closest distance. If this was me, for example, and I wanted to walk to the green line, the shortest distance isn't taking a path this way, right? That clearly is not the shortest distance. The shortest distance is also not this distance. It's not this distance, okay? Of course, the shortest distance is roughly that line right there. And it's called the perpendicular distance. This angle right here is 90 degrees. That's why it's the perpendicular distance, because to go from one point to another point, or from one line to another line, or from one point to one line, the shortest way is to take the perpendicular distance. So that's what we're going to be talking about today. Now when we find distance on a coordinate grid, the way we do that is we use the distance formula. So let's have a quick reminder of what the distance formula looks like. The distance formula is the square root of subtracting the x coordinates and squaring them, and subtracting the y coordinates and squaring them. So let's quickly find the distance between these 2 points. So the distance is, let's subtract the x's, a -3, subtract the -7. That quantity squared, plus, now let's subtract the y's. -5 subtract the -2. And that's all underneath the radical. Going down one step further, a -3 plus 7 is 4, and 4 squared is 16. A -5 plus 2 is a -3, squared is a +9. So we get the square root of 25. So the distance from those 2 points on an XY coordinate grid is 5 units. Let's also refresh how to draw a perpendicular line between a point and a line. So let's see, here's the point. So what we're going to do here is we're going to attempt to draw this line roughly. Okay, it's going to be the perpendicular line from the blue point to the red line. And we're going to use that using a compass. So here's how we do this. We're going to put the needle on the point. We'll open up our compass. And the stipulation here is we have to open up our compass enough so that it intersects the red line 2 different places. So once right over here and once right over there. So there's the arc that you're going to draw. Now that you have this, you're now going to put your point at one intersection, and you're going to make an arc. Open it up a little bit. You're going to make an arc below the line, and then you're going to make an intersecting arc using that same compass setting. Put the needle at that intersection, and now you're going to make an X over here. And now you're going to take a straight edge, and you're going to connect the point right through that X. And there you have successfully constructed a perpendicular line. We're going to be doing that several times today. So we're going to be doing this geometrically by using a compass. I'll also show you how to do this algebraically using slopes. So what we want to do here is we want to find the distance, and when we want to find the distance, it means the perpendicular distance. It's the shortest distance between a line and a point. So the line contains points -6, -9. So let's go left 6, down 9. and 0, -1. So that's a line, and we'll connect those points using a straight edge in one moment. And the point is left 7, down 2. So we want to find the distance between the blue point and the 2 green points, which we're going to make a line out of that right now. Let's find the slope of line M, which is between these 2 points. Let's find the slope there. We could use our slope formula. Because we have a grid paper, I'm just going to count it out with the rise over the run. So it's a rise of 1, 2, 3, 4, 5, 6, 7, 8, and a run of 1, 2, 3, 4, 5, 6. The slope is a rise of 8 and a run of 6. So 8/6 is our slope. And what does 8/6 reduce to? Of course, it reduces to 4/3. So what I'm going to do now is I'm just going to write out our slope for as much graph paper as we're given. So a rise of 1, 2, 3, 4 over 1, 2, 3. Up 1, 2, 3, 4 over 1, 2, 3. Up 1, 2, 3, 4 over 1, 2, 3. Up 1, 2, 3, 4 over 1, 2, 3. All right. Now we can take our straight edge and let's connect all those points. So now we want to find the distance from the blue point to the black line, line M. Okay? So now what we're going to do is we're going to construct the perpendicular distance, and we'll do this geometrically first. So I'm going to take out my compass. I'm going to put my needle on the point. And I'm going to open it up so that it intersects my black line in 2 different places. Once right there. Oh, let's try that over again. We'll open it up a little bit bigger. Once right there. Once right there. Okay. Now that we have that, I'm now going to put my needle at one intersection. Maybe I'll open it up a little bit more. And we'll draw an X here, or one part of the X right there. And then we'll go down to this other intersection and we'll complete the X. And now we will connect the point and that X that we just drew using our straight edge. Right like that. So class, what is the distance from the blue point to line M? Well, the distance is the distance from here to where it intersects with that perpendicular distance. So right there. We want to find the distance of this line, right? So when we want to find the distance, we want to label the 2 points and find the distance between them. So the point is at -7, -2. It stated that up top. And then the intersection, that perpendicular line that we drew, intersects at left 1, 2, 3, down 1, 2, 3, 4, 5. -3, -5. We want to find the distance between those 2 points. So to find the distance equals the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. And I believe this is the same problem that we had as our practice problem when we did the distance formula. -3 plus 7 is 4, and 4 squared is 16. -5 plus 2 is a -3. Squared is a +9. So the distance from the point to the line is the square root of 25 units, which is the same thing as 5. Now I also said, like, this is how you could do this geometrically. If you wanted to do this algebraically, you could do this algebraically as well. If you'll notice, let's see, forgive me here, class, I'm just trying to, here we go. I just wanted to get this back to the way the original information states, which is I have a point at -7, -2, right here, and I have a line, and I want to find the distance between the two. So the perpendicular distance is the distance that I want to find. And the perpendicular distance, well, if my slope is 4/3, what is the perpendicular slope? So I said you could find this geometrically by using our compass. If I wanted to find this algebraically, I would say, what is the perpendicular slope to 4/3? It is the negative reciprocal, a -3/4. So from this point, -7, -2, I could do a slope of down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Down 1, 2, 3, over 1, 2, 3, 4. So this is the perpendicular line, and as you can see, it still intersects at -3, -5. So that's how you could do this algebraically as well. Let's practice another one. This time we want to find the distance between two lines, and they're parallel lines. You can see that the slopes are the same. So we'll first graph the line y equals 2x minus 3, so a y-intercept of down 3, and then it's a slope of up 2 over 1, up 2 over 1. So I'm just going to quickly draw this for as much graph paper as I'm given. And now we're going to graph the other line. This time it intersects at a +3 for the y-intercept. And then it's a rise of 2, run of 1. So you can see very quickly that the two lines are parallel. They have the same slopes. And I want to find the distance between these two lines. So again, the distance between the two lines is the perpendicular distance. The quickest distance between the blue line and the red line is not this kind of a distance, right? That's just silly. The perpendicular distance is the one that goes, that's perpendicular to it. So let's first construct that using our compass. So because we don't have a specific point that we want to go through on this one, we could pick any point for our starting point. So I'll just pick the y-intercept with this blue line. And we're going to construct a perpendicular line. So from here, I'm going to open up my compass so that it intersects the red line at two different places. And then at each one of these intersections, I'm going to put my needle, open up my compass a little bit, and I'm going to draw an arc below, and then going at this other intersection, I'm going to make the intersecting arc. Whoa. Should have made my other arc a little bit bigger. There we go. Now we'll take a straight edge and we will connect the point 0, 3, which is where I started, right through that intersection. Right there. So now you'll notice on this one, the intersection right here is not at an integer point. So what I'm going to have you do, class, is I'm just going to have you estimate where that spot is. We want to find the distance between 0, 3, and this point, because that point is that perpendicular intersection, and I want to find the distance between those 2 points. So on my notes, I know that we might have some disagreements here, but on my notes, to me, it looks like that intersects at approximately 2.3 and 1.8. This point right here is roughly 2.3 and 1.8. So we're going to find the distance between those 2 points. So it's going to be the distance equals the square root of 2.3 minus 0, that quantity squared, plus 1.8 minus 3, that quantity squared. As we continue, 2.3 minus 0 is 2.3, and then if we square that, we get 5.29. If you take 1.8 minus 3, it's a negative 1.2, and if you square that, you get 1.44. So the distance between the red line and the blue line is the square root of 6.73. And the square root of 6.73 is approximately 2.59. The distance is approximately 2.59 units. So I could have picked any one of these points as my reference point. I could have picked that one, I could have picked that one, I could have picked that one. And then when you construct that perpendicular line, it's not going to be at a specific ordered pair. So you're just going to kind of estimate. And we estimated that this point right here is right about 2.3 and up approximately 1.8. So once you do that, you find the distance between the two of them, and the distance between the red and the blue line is roughly 2.59 units. We finish off with this one, and it's the easiest one of the day. What is the distance between these two parallel lines? Y equals 5 is a horizontal line. So we're just going to go up 1, 2, 3, 4, 5 units, and we're going to draw a horizontal line. We're also going to go to y equals 13 and draw another horizontal line because y equals 13 is a horizontal line. So 10, 11, 12, 13. Here's the line y equals 13. So what is the distance between the two? I could take out my compass and I can draw a perpendicular line and stuff like that. But what line is perpendicular to a horizontal line? The answer is a vertical line. So what is the vertical distance from this point to this point, or from the two lines? So you can just count the distance from one to the other. It is 1, 2, 3, 4, 5, 6, 7, 8. Or you could just subtract 13 minus 5. The distance is 8 units. You could do the same thing if I gave you two vertical lines. If it was x equals 2 and x equals 12. What is the distance between those two vertical lines? Well, it's the horizontal perpendicular distance. You just take 12 minus 2 and get 10. So I hope this made sense to you. We're going to have a worksheet on it when you get to class tomorrow. If you have any questions on that worksheet, be sure to let me know.